welcome everybody. Thanks for coming to this talk. My name is Honza Horak and I'm working in Red Hat. I'm one of the developers of the software collections, which this presentation will be about. And I'm also involved slightly in Fedora, CentOS, and generally the platform development in Red Hat. So what about you? Are there any developers or people who think there are developers or develop at least something? Good, there are some. What about administrators or, okay, even more of them, great. Thank you. So why I'm giving this this talk is because many people have this particular problem. On the enterprise Linux or systems, there is usually only one single version of a software. So a short story in the beginning. I had a friend who wanted to develop an application on an enterprise system for Red Hat Enterprise Linux 7. And he also found a nice application already developed. It was written in Python 3, and it used MySQL 5.6. So he asked, what should I do, actually? Because, as we know, Red Hat Enterprise Linux 7 includes only MariaDB 5.5 and Python 2.7. So one thing he could do was just remove those packages and install the new versions. But you know that dependency hell that would come, it wouldn't probably work at all, because Yum, for example, is only working in Python 2.7. So what I advised him to use software collections, because we can't break just, we shouldn't rather touch packages in the base system. We should rather include something which doesn't do any changes in the base system, which the software collections are all about. So the software collections allow you to use any version of any software on your system and all these versions together. So this is the main point of the software collections. So I will show you in several practical examples that it is possible. It is possible quite easily, and it is possible also quite safely without affecting the rest of the system. So these days, or these months, maybe even years, we talk even or more and more about containers. So this talk is not primarily about containers, but there will be something in the end that is connected to containers. But the concept itself, the software collections, is not container-based. So this is what I would like to cover. First, the principles of the software collections. Maybe this is a great time to ask you if anybody already tried the software collections, or, okay, some of you, great. Then I will shortly cover what it is about to package RPM as a software collection. Then I would like to mention some news in the Red Hat product, which has been released 3 weeks ago, I guess. And in the end, as a dessert, software collections and containers, some thoughts and examples about this. So all these examples will be showed, or the examples will be based on the software collections version 2.0, which are coming from Red Hat. So the product is called Red Hat Software Collections. So this is just a quick example how we can gain software collections on your Red Hat Enterprise Linux 7 machine. We just need to enable correct repository, and yeah, that's basically it. And now we can work with them. So first, what I would like to show is why. Show few borders that were set up in the beginning when we started to create the software collections. So the concept is based on the RPM. So it means, or it allows us to make the packages quite easily. They are also quite easy to use, and however, we need to keep in mind that there are, well, if there are some disadvantages of RPMs, there will be probably here as well. So RPM doesn't work for everybody, but for most of the use cases it works quite well. So we used all these advantages as well for the software collection. So it's a concept based on the RPM. When we talk about packages in software collections, we basically talk about three types of packages. So first, the packages we actually need some functionality from. So for example, Postgres database or Ruby on Rails stack. So these packages bring us some features. Then in one software collection, there are also dependencies that are not available on the system. For example, some newer version of libraries that may be, for example, the Boost. And there is one special package which is called meta package, and this package basically describes the collection. And when we speak about the principles, so when we want to deliver an alternative version, maybe older or newer version of the package, we need to solve conflicts, because we can't just conflict with the base system. So let's take a look where we can conflict with the base system. So there are basically three levels, three places where we can conflict. So first, packages names can't conflict with the base system. So let's take it closer about this. We already enabled the repository with software collection, so we can actually install the software collection. So let's pick MongoDB as a first example. So I've installed the RH MongoDB 2.6 collection, and as you see, all the packages from the collection which we installed are prefixed with the name of the collection. So this is quite simple way how we can avoid conflicts on the package name level. So again, all the packages in one collection are prefixed with the collection name. So that's quite easy, and we have first conflict solved. So there is another one. We can't conflict on the installed system. So it's basically one file from one package can't be different or the same with a file from another package. You know these errors like RPM conflicts with another RPM. So this is about it. So how we can address this in software collections? We can show, or we can look at the files which are basically delivered by the package from the software collection, well, from the MongoDB package. And we see that the paths are quite different. So most of the binaries are just placed in the OPT, RH, and a subtree that actually contains the name of the collection. So it basically can't conflict with any other collection or the files from the base system. And there are also some files that need to be on some expected place, for example, systemd unit files. So these files can't be in alternative directory, but we can solve the conflict by prefixing the names of the services of the files by the collection name. So you see that even the system unit files can conflict with base system or other collections. So the second problem solved, and the last one, RPM metadata. So when we create RPMs, some metadata or requirements, provides and requires are generated automatically. Some are generated manually. But all these need to be also with no conflicts with other stacks or with other packages from base system. So this is example how it is solved in MongoDB package, that every provide has again the software collection in the name. So when we have solved all these conflicts, we are basically done. So how do we make it actually? How do we add the collection names to file system and to packages names? There is one package only that is necessary for all this. It's called scl-utils. There is runtime support already in this package, and also the build time support. So when you need to build a software collection, you will need the scl-utils build package. When we need to run the software collection, then just the scl-utils package is necessary. So yeah, let's install another package, the Python collection, and we will see that the Python collection, as after we installed the collection itself, actually includes quite a lot of packages, because this is the set of packages that we consider basic. So after installing them, we can try to run it, try to run the Python 3.4, which is obviously not in the base RHEL 7 system, which we can check like this. In the base system, there is just the 2.7 version. But when we can run Python 3.3, which, well, it was not showed the install of this collection, but let's say we did it. So using SCL enable and then name of the collection and command, we can run these alternate interpreters. Yeah, it works even with the interactive mode, no problem there. And maybe you are wondering, what is it all about? Well, why does it work like this? So let's take a closer look. So when we are on the RHEL 7 and we just see which binary it is actually when we run Python in bash, it is basically user bin bash, user bin Python. However, when we run scl enable, name of the collection, then when we check the Python binary, it is located somewhere else. And the whole magic behind this is that path environment variable was adjusted by the scl enable command. And so the bash finds the binary in alternative directory. That's all. That's all the, well, magic is probably not the correct word, because it's quite simple principle. So similarly, it works with libraries. We just adjust LD library path. Similar, it works with man pages, etc. So when we want to work with daemons, it's even simpler, I would say, because yeah, obviously we don't have MongoDB daemon on RHEL 7, but as I already said, it's enough to look how the system unit files are called and approach the services by its correct name, which is prefixed with the software collection name, and yeah, we can work with the daemon even without calling SCL enable explicitly. It's basically because we need to enable the collection during the daemon start itself, because every daemon, when started using using systemd, it started in clear environment. And as I said, this concept is based on changing the environment, so we can do it implicitly when starting the daemon. When we want to change some configuration files, the only thing we need to care about is the path that we need to choose or edit the correct file. So in this case, it's located in etc, opt, rh, etc. But then, well, we can edit the file as usually. So yeah, I will skip this because it's not that important. Yeah, and now we can run the MongoDB server as usually. Now we can add some data just to show some interesting things later. So we will create a database DevNation and create a collection in the MongoDB database, which is named talks. Okay. My typing is really slow, so I will make it quicker. So we just inserted 2 documents into the database DevNation. So let's see how we can work with the software collections. So the example application will be based on the Python 3.4, which we just installed, and the MongoDB database, which we will grab some data from. So what we will need above the basic set of packages from Python 3.4 collection is the pymongo package, which is the connector for MongoDB. So we just install it. Yeah, that's it. And now we can write the application. As you see that, well, actually, what is different in this program that can tell us that we are actually working with software collections? Does anybody knows? Well, how? Yeah. Yes. Exactly. That's the only thing that can somehow that can be like a signal that we want to use software collections. So the answer was the first line, user bin env, which basically runs the Python based on the environment. The rest of the program, and it's quite nice about the software collections feature, is basically without any changes, any specifics to the software collections. So we can basically run any Python code as a software collection, and the same works even with the database. So based on the line which contains the localhost and port, we are basically not able to say whether the database will be software collections or not, because when we choose defaults for the daemons, we basically choose the defaults from the base system. So the ports and, for example, the AP's conflict with the base system, which means I'm not able to run MongoDB on the base system and from the software collections at once without changing the configuration. But the only thing I need to do is changing the port. So these both programs won't conflict. Okay, question?
So I think you're actually dancing around my question, which is, can you run 2 Mongos of either 2 different versions?
Yes. So the question was whether we can run 2 versions of MongoDB, for example, at once. Yes, we can. The only thing we need to change is the port number that every version will run on. So because the defaults are same, but this is really the only thing. It works the same when speaking about the software collection, for example, Postgres and Postgres from the base system. Both can be run at the same time. You just need to solve the ports. Okay, so this is just an example that it really works. Okay. And slight example or simple example how the packaging works. So how we can actually create packages to be software collections. So this is really the example how I started. I just download some package from the Koji build system. These are the bits I start with. So let's say I wanted to work with dates in some advanced level. So for this purpose, there is a nice package, Python dateutils. So I downloaded the source RPM. The cursor was not shown, so this was this link. And what I do now is to unpack the source RPM by RPM minus I, sorry. Rename the spec file so I don't have Python 3 in the name, in the base name, because I will actually have the version in the collection name. And these are actually the changes we need to do. All these changes are documented in the packaging guidelines, which are available on softwarecollections.org webpage or in the documentation for the Red Hat software collections. So what we did was some macros adding for the software collections itself, changing the package name, and also changing the dependencies. You can see that some dependencies were changed to include the prefix and some not. So the TZ data doesn't include the prefix, and I will ask why, if anybody knows. Why the TZ data package doesn't have this SCL prefix? Yeah, okay.
There's only one, and you're not going to need a special.
Right. So all these packages with the prefix are from the collection, while the TZ data is actually the one from the base system. So there is not TZ data package in the software collections, or in the Python 3.4 collection, but yeah, we want to use the one from the system. So yeah, that's it. And there are a couple of other changes that we need to do, and these are that we need to run all the scripts within the RPM with proper environment, which means we call SCL enable in the beginning of every section. And yeah, we're using here doc to make it a bit more readable. So yeah, it was closed. These were the changes, calling SCL enable 3 times. And that's it, really. So we can try to build the package. We build it almost in a usual way, except that we specify the SCL that we built the package for. We do it this way because we can have then, well, some packages may be common for more collections. So this way, we can have one spec file, one source RPM, and build it for several collections. So this is the reason why I specify the collection name during the build, not in the spec file. Okay, the package seems to build successfully. Yeah, it does. And we can use it. So just installing the build package means we are running yum install, and we can, yeah, this was closed. So we can now try to use this dateutils package in the Python. Okay, it was quite slow, so let's make it faster. And we see that the datetime parsing actually works, so it proves that the package is there. So when we have some collection and it includes, for example, 20 packages, it's not always enough. So maybe we will need to add some package to our needs, to offer new features that is missing in the software collection as delivered by Red Hat. So these are not 2 but 3 ways. This is a typo. So the first thing is what we actually did. Build a new package into the collection and install it. So when we are authors of the collection, so if you create your own collection, this is probably the case which we will use. When you are just consumer of the collection, I would recommend one of the one of the other solutions. So either use some native package manager like pip, npm, gem, or to create a dependent collection. And dependent collection means basically creating a new collection that includes your missing packages and includes the dependency on the original collection. This way, you can keep the environment strictly defined. So the packages built by someone won't conflict with packages or will be separated from packages built by Red Hat, for example. And there is a nice article on developer blog redhat.com how to make it. So just follow the article because this is a bit more complicated, but it's still not a rocket science. So just follow the link to learn more. SCL-utils, the package that actually enables the building and using the collections, includes now quite nice features. There are features that are already part of the Red Hat software collections product, and these are SCL register, and I will tell something more about this later, so let's just mention it quickly here. And another change, quite significant for the user, is that location of some variable and configuration files was changed. And the reason was first that it's connected to SQL register, as you will see. And second was that also the file hierarchy standard actually defines the new location for these files. And there are also features that are not part of the RHEL product yet. And this is, for example, the environment module support. So if anybody knows environment modules, he probably knows that it's a bit similar concept to software collections. So this is this new feature actually merges those two concepts. So what we will be able to do, or we are able to do with the new SCL-utils from the upstream, is using the collections also by calling module binary. And this is actually what the SCL register feature is quite handy. Let's say we have a server and we have multiple clients. And what we want to do is to have the same environment on every client managed easily, and ideally also not be able to change the environment on the client. So this is one approach which can be used with software collections. Basically, we create the environment by installing software collections or packages, basically. Not only software collections, but also their extensions on the server only. So this is how we can do it. We will again install the Python collection there. And since we already saw that, I may be quicker. Code. Okay, so and what happens on the client after we mount the OPT directory there? So as you remember, all the files from the collection are placed in the OPT directory. So let's say we have mounted this directory from the server on the client. We see that there are no packages like RH-Python 3.4 installed, but there are these files in opt RH-Python 3.4. So we will probably be able to run the SCL enable, right? Yeah, and another thing I already mentioned it. We don't want to change the environment from the client, so the mount is read-only. So yeah, that's it. So let's try run SCL enable. Well, and we see that it actually didn't work. It's because not all files from the collection are actually placed in the opt directory. There is one special file in etc SCL, and this is the right time when SCL register comes handy. So we call SCL register and then path to the mounted directory with the collection, and we see that now we can run the SCL enable safely. So let's try it. We'll run bash with the software collection already enabled, and we see that there is already Python 3.4 available. So that's basic. That's the basic stuff in the NFS mounting, but well, so far we needed to run some command on every client, which might be not worth the troubles with mounting. But what I like even more is that as soon as we run the command or the SCL register once and we mount the collection once on the client, now we can work purely on the server. So let's say we want to add some more packages on the server. We'll install, for example, a Python Mongo client there. Okay, it's installed on the server. And let's see whether it will be on the client. Any guesses?
So is the server side just the etc exports file? Is that just exporting the op directory?
Well, it actually, yeah, the question was whether the directory exported is the OPT. So it depends basically on the administrator. It may be the whole OPT. It may be only the collection directory. It depends on the needs of the administrator.
On the slide before this, where you showed that you had to run that register command to register the config file, what does that do on the client side?
So basically, as we saw, there was this file missing. So the register basically, well, it's not that simple, but basically it just creates these missing files that are not available in the OPT directory.
So the NFS-server that's exporting doesn't have to export that etc SCL directory or anything like that?
No, this directory etc SCL is not exported on the server, right? Only the OPT files. So that was actually the use case. All right, so we install the PyMongo package, and yeah, you already saw that the Python Mongo package is actually available on the client as well. So since first registered, the collection now can be adjusted only on the server. So that's quite nice. But still, we need to keep in mind that there are no actually packages installed on the client. So some scripts that check availability of some service by asking RPM database won't work because RPM database on the client doesn't know about these packages. So what collections are available yet? Of course, there are some. And as I said, there is a Red Hat Software Collections product. It was released 3 weeks ago, I guess. And it actually adjusts or it adds new collections above already available set of collections, and also updated others. So on the left two columns, there are collections that were already available before, and the best column is the right one. It's the set of new collections available since 3 weeks ago. So what the packages are actually, there is a Ruby on Rails new version of that. Not the latest one, but the latest, well, almost the latest one, and that we consider stable enough. It works above the Ruby 2.2 collection. So let's see what Ruby 2.2 offers. And there is one quite simple feature, but it was asked by many users. It now includes the bundler, so you don't need Ruby on Rails collection anymore to use the bundler in Ruby collection. Then there is a passenger which nicely works with other collections from this product as well. There is a new version, or the latest version, from Postgres database with great JSON support. There is a new version of MongoDB 2.6, which we already saw. This collection also includes the Mongo Java driver in comparison to other drivers that are usually included in the collections, like Python, Ruby. But since we don't have a Java collection, so we included the driver here. There is MySQL 5.6 with nice features supporting the replication, for example. MariaDB that actually includes even more features. And yeah, this collection also includes the PAM authentication plugin. Python 3.4 also something which we already saw. And one quite important thing is that there is actually the pip binary or package already included, which was missing in Python 3.3. PHP 5.6 with also a couple of nice enhancements, and last but not least, Parallel 5.20 with nice HTTPD 2.4 cooperation. So these are all collections that you can use already, but of course, if you miss something there, we would like to learn. If you want to create your own collection, you are free to do it. And this is the last piece, probably. So what I was speaking in the beginning was that software collections are not containers, but there are a couple of things or thoughts that actually makes these two technologies a bit, well, friendly. So this is the question for you. There is a package inside the container. Is it software collection or not? Well, how could you know it, right? But that's actually the answer. We don't actually care, because the container allows us to deliver the software collections without the need to run SCL enable and handling all the weird paths issues. So, for example, these two containers with MongoDB or Python with some application offer the API, or I call it API, but it in containers it basically means which port the MongoDB runs on. In Python, it means where this container expects the sources for the application. So this, what I call IPA of the container, is basically the same for the packages that are software collections or not. So what I mean by this is that we don't need to care whether the collection is inside the collection the container, or whether there is a usual package. In our in Red Hat, it saves us a lot of work because we can have one package, one stack of, for example, Python or databases, and we can package it in more ways. So we don't have to do the work twice. It may work the same for you. And I would like to show an example with Docker actually, but it may be applied for generally every container technology. So let's say I have pulled the collection, or I would rather say the stack Python 3.4 or the Docker image. And I ran Docker run command, so some usage information was printed, so I can use the Docker run as described, running the bash inside, and I see that, or we see that there is already Python 3.4 available. Again, there is no need to run SCL enable within the container. Already is done for us. So that's one example. Another example may be how to extend the Docker container. So let's say we want to create an application with Flask, a nice framework, but as we see, there is no such package in the container because Flask is not part of the software collection Python 3.4. So what we can do is to create another layer, another Docker file or Docker image, which will include the application. This is actually the application itself. It just prints the, yeah, is there? Okay, so the application just prints the Python version. It didn't do anything else. And there is another script, which is just a shell script that installs the missing package using the pip installer. And the last piece missing is just the Docker file. We will base this application on the already pulled image. We will just add the script to install the missing Flask package, run this script, and then also define the application itself as a starting point or default command. So now we can build the application and try to run it. So it shows us that it runs on the local host and port 5000. So let's try. Okay, it runs, and it also prints the correct version of the Python. There is not only one Python in the container. There is still Python 2.7, which is also accessible for tools that require it. For example, the YAM still requires Python 2.7. So when you install files in the or packages in the Docker file script, you are able to do it. The fact that we have Python 3.4 as default doesn't prevent this, so that's quite a nice feature. And yeah, we probably need to get some data in every database. Every application. So let's show. Let's run the MongoDB image as well. Again, I've just pulled the MongoDB 2.6 container or image based on the software collection. When running it, some usage information will be printed, and we see that this image actually offers some additional arguments to be passed as environment variables. So we just follow documentation and run the MongoDB Docker container, and we will see that after specifying some initial data, this means the database username and password to be created during the database initialization. It is quite fast to have a running instance of MongoDB with already provided or already created database and having access to this database. So we will extend this application with grabbing some data from the MongoDB. So it's basically about connecting to running instance. And I'm not using localhost here because in Docker world, we can link two running containers with the -- link option. We'll see it later. And then access these, for example, running port and running address using environment variables. So this is actually an example of exactly this. Yeah, then we will grab some data from the DevNation database, and okay, I will skip this, and this is basically about printing the data from the task collection. We need to add the data as well. Yeah, this is also one important step. We need to add Python Mongo driver there as well. And as I said, we need to also add some data to this running container when yeah, and for adding some data, we need to obviously have the container running. So this is what I was actually talking about. With -- link option, we can link the two applications together. We will first run the MongoDB. We already did it before, and now we can link these applications together. So my app is the Python application, MongoDB is the database application. So we will have two running containers. And as I said, we need to add some data. So finally, this piece. So running Docker exec, we will just connect to running container, and we can use Mongo shell to insert some documents into the database. Okay, just 2 documents is enough. And now we can check whether it works, and it seems it does. So yeah, so again, what we did was we have one container with MongoDB running and another container with Python collection running, extended by our application in Flask. Okay. Yeah. So yeah, when we want to read some documentation, talk about issues, create our collection, extend the collections that are already existing, where we can go. So this is actually one problem we are focusing right now. We are trying to create a nice community about the software collections, and this is the way we do it. We've created a special interest group within the CentOS, and we also want to encourage all of you to join this effort. So this is this should serve as an upstream for software collections in the future. So you are free to join. You will be really glad if you do it. There is one site, very important site for the software collections concept. It's called softwarecollections.org. That's basically the first place I would go when I need to search some things about documentation, about existing collections as well, because this site also includes the directory of existing software collections that are freely available. This is not about the software collections available by Red Hat, but this is about more the upstream. So yeah, visit this page and look especially about the guidelines and browse the collections you need. And yeah, that's basically all from me. And we have probably 2 minutes, 3 minutes maybe for questions.